Hey y'all, welcome. Yeah, so I hope my love Christ Jesus is with you and everything that you do. I hope you're having a great day. And yeah, so like a while back, maybe like 2 years ago, I made this integral and called it the hardest U-substitution problem. So if you attack it using U-substitution, there is a long and scenic, interesting path to getting to the final answer, right? And while another viewer suggested a different approach, Ernest, in his own words, a man of 58 years who's Dutch, wrote up a solution that solved the integral very efficiently. And so I wanted to share that solution. And so then, you know, aptly, I'm going to name this the Ernest. And I'm pretty sure I got the last name right. Both first name, last names, I told him really cool names. And it's Sean Makers. Okay. Integral. Right? Like the closest name to this that I remember is like as a child, for whatever reason, I used to watch the Formula 1 Grand Prix, and there's like a very, very good racer called Michael Schumacher. And it just so happened while I was tutoring in Westchester, I tutored a kid who is super cool by the same exact name, Michael Schumacher. Well, this is not Schumacher. Ernest, you can correct me. I think Sean Makers. Okay, but still really cool. All right. So this integral, of how you do it off memory, went a little something like this. And it's tan inverse of x over 1 plus 1 over x squared dx, right? Okay, so if we take the Ernest path, this is what it would look like. So first of all, like this right here is x squared over x squared. We can write 1 as such, so this is x squared plus 1 whole over x squared, right? And then your key flip change would have one right the following, right? So it'd be like x squared tan inverse of x all over 1 plus x squared dx. So thus far, I have not done anything but mere rewriting of the original integral, right? Okay. So where to from here? Well, as I suggested in the previous solution, what we're going to do is this. So we're going to take x squared. Notice x squared is multiplying tan inverse x. And we're going to add 1 and then subtract 1. Right? And in doing so, we didn't really add 1 and subtract 1. Technically, what we did is add and subtract tan inverse x, right? To the numerator. That's what we had done. Okay, cool. So we go over, and then it's 1 plus x squared, same as x squared plus 1, right? Okay. That too is like, okay, my bad, y'all. Alright. So then now what? Well, we're going to split the integral over that minus sign. So we're going to write, and of course we have to distribute this tan inverse as we do. So I'm saying let's group this way. So this times tan inverse and then minus 1 times tan inverse. And obviously, you know, the common denominator will go in both integrals. So x squared plus 1 tan inverse x over x squared plus 1, right, dx, and then minus integral, and then it's going to be tan inverse x over x squared plus 1, which is 1 plus x squared dx. Let's call this integral b, and so the a integral is right here, right? Now, so for the a integral, notice we could do this, right? So a is simply the integral of tan inverse x dx. Now, a while back, I made a video on how to integrate this. It's a fairly basic integration by parts problem, and so I'll share that video, and therefore not gonna, you know, go through the motions or reinvent the wheel here. So if I state the result correctly, I think it's going to be x tan inverse x minus the natural log of the square root of 1 plus x squared. You've got to admire the memory in my noggin, right? Okay. Alright, so the A integral is done. The B integral is fairly straightforward. Seeing 1 over 1 plus x squared and tan inverse x together, y'all must be excited. In fact, I'm pretty sure there's nothing more exciting on your day than this, right? So for B, I'm saying, like, to make it abundantly clear, we could write the integral as follows, which is as tan inverse x and then times 1 over 1 plus x squared dx, right? Okay, wherein one reckons that if we call this u, so we're going to do basic substitution or U-Substitution, it's pretty obvious that this here is du. So what we've got is integral u du, which is u squared over 2, and we already threw a plus c there, like, because we're going to put them together, right? And remember, the b integral is being subtracted. And so, this, I'll throw another plus c. And so let's call this C1 and this C2, just like for formality's sake. So obviously, since we called U tan inverse, what we've got is some really cumbersome writing here. Tan inverse x squared over 2, and then plus C2. So C1 and C2 will combine to a C, so our final answer, we go A minus B is our final answer, right? So A minus B is going to read x tan inverse of x minus ln square root of 1 plus x squared, and then minus the b integral, which is copy and paste, tan inverse x squared over 2 plus c. Yeah? That too. Alright, y'all. Hope you're well. Yeah? Take care.